This is higher homework 4. We're looking at question 10. Find the coordinates of the stationary points of the curve with equation y is equal to a third x cubed plus a half x squared minus 6x plus 2, and using differentiation determine their nature. Okay then, so this is a typical type of question that you could see in your exam. What we have is a curve that we're looking for the stationary points. So first thing I'm going to do is I'm going to differentiate, and I'm going to set the gradient equal to 0, because stationary points occur where the gradient equals 0. So let's go ahead and differentiate first of all. So dy by dx is going to be equal to, so 3 times a third is going to be 1, so that's going to give me x squared coming out there. So 2 times a half will give me 1 again, so that'll be just x when I drop the power down, and minus 6x will give me minus 6. Okay, so remember when we're differentiating, 3 times the number at the front and reduce the power by 1. 2 times the half and reduce the power by 1, and similarly along. So the 2 just goes to 0. Right, so for this I said that this is going to be the gradient, okay, the gradient formula. So for stationary points, I say that dy by dx is going to be equal to 0, and I'm just going to set that up in this way here. So that's it, set equal to 0. What I'll then do is I'll try and factorise this part here, so I'll put it into 2 brackets. So I've got x here, 2 numbers that multiply together to get 6, so I've got 2 and I've got 3, and one of them's negative, and if that one's negative, one of them's negative, and that's a positive, the biggest one must be the positive. So that's me factorise that out. From there I can say that x minus 2 equals 0, and the other part I've got is x plus 3 equals 0, so x equals 2, x equals minus 3. So that's me got my x coordinates of the turning points, or the stationary points, as they may be. Right, so what I'll do next is I'll find the y coordinates. So to find the y coordinates, what I'll do is I'll substitute x equals 2, then x equals 3, and we'll put that into the main equation that says y equals, because I'm trying to find the y coordinate. So if I substitute in the x values in to here, I'll find the y coordinate for each of them. So let's do the x equals 2 first. So I'm going to go for y. I'm going to substitute a 2 in, so that's going to be 1/3 times 2 cubed plus a half times 2 squared minus 6 times 2 and plus 2 at the end. So just substituting wherever I see x, I'm going to put the x equals 2 in there. So just to sort this out, I've got 8/3 here, I've got 4, half of 4 is 2, got minus 12 plus 2, just working that through, that's 2 and 2/3, minus 8, and that should give me minus 5 and 1/3 coming out there. So the coordinate that I've got from here is going to be 2, because I've said that x is equal to 2, and my y coordinate is minus 5 and 1/3. That's my first coordinate there. So what I'll then do is I'll put in it's a minus 3 that we're going to put in here, so I'll change that to a minus. So if that's a minus 3 going in, I've got 1/3, that would be minus 3 cubed, plus a half, that's minus 3, and that's going to be squared, minus 6 times minus 3, and I've got a plus 2 on the end. So that's me fired in the minus 3 going in there. Right, so that will give me minus 27. Minus 27 divided by 3 gives me minus 9. That will give me 9/2, so I can just put that in like that. That will give me plus 18 and plus 2. So gathering some bits together, I've got 11 plus, I'll just call that 4.5. And my final answer to this one here will be 15.5. So my coordinates of this point here, minus 3, and I've got 15.5. So that's me got my coordinates of the stationary points. I just need to define what their nature is, and I'll do that by using a nature table. Right, so on this nature table, what we'll do is we'll get some values going along the way, and the values here will be some x values that I've got. Right, so what we've got here is I've got x. The points that I know, there's -3, so that'll be one that I'll get here, and I've got 2, and what I want to know is a value coming towards here, a value in between these two, and a value going away from 2. And what I've got here is, on my nature table, it'll be the dy by dx, and that'll be x squared plus x minus 6. Okay? And I know that these values here will be 0 because I've already tried to work that out, and I set it equal to 0 to find these values. Okay? Right then, so here we go. Remember, when you set up your nature table, make sure it's dy by dx that you use in here. Okay, so what if I take -4 and I substitute -4 in here? So that'll give me 16. 16 minus 4 minus 6 will give me 6, so that's going to be a positive value that I'm going to get out of there. So let me take a value of 1 going in here, because that's between -3 and 2. So if 1 goes in here, that will be 1 plus 1 is 2, 2 take away 6, so that's going to be a negative value that goes in there. So I'm interested whether it's positive or negative. And beyond 2, if I take the number 3, so 3 into there would be 9, plus 3 is 12, 12 take away 6 is 6, so that's going to be a positive value that's going in there. Right, so what I can say is that the shape of the graph, or the nature of the graph, is going to be positive here, flat at this part here, negative going down this way, flat and positive there. So I can see that this is a minimum in here, and this is a minimum at, and this is going to be the point where I've got 2, and it's 2 minus 5 1/3. And here that's a maximum because it's turning at the top, okay? And that's going to be where x is -3 and the associated y coordinate is 15.5 there. So why don't we just make a statement and finish this one off? So it's a maximum. Turning point at, and we'll go for -3, 15.5, and a minimum turning point at, and it's this coordinate here, so it was 2 minus 5 1/3, and that would be the question complete, because what I've done is I've worked out the stationary points, the coordinates of them, and I've worked out their nature and made a statement to that effect. Right, let's see the marks here. So we've got 8 marks that we're looking to give for this question. So first mark that I'm going to go for is knowing to differentiate. So if I've got dy by dx and something after that, then I'll take a mark for that. 1 mark for differentiating correctly. I'm going to have 1 mark for setting it equal to 0, dy by dx equals 0. I can show it there or down here, okay, as long as I'm showing it. And 1 mark for factorising out, and 1 mark for getting the x values. I'll take another mark for getting the values here, okay. I'll go for a mark for setting up the nature table correctly, and 1 mark for a final statement. So that should be 1, 2, 3, 4, 5, 6, 7, 8. So this question here, out of 8 marks, and quite a standard type of question for your exam.